This video is going to review two sample hypothesis testing, looking at the difference between means and assuming small independent samples. And recall that for samples larger than 30, we would use a z-score, z-test. For less than 30, we go to the t-distribution, which allows us to adjust by degrees of freedom. But like the z-test, it assumes randomly selected samples that are independent and a normal distribution. The two-sample t-test has the identical statistic equation as the z-test. This part down here is slightly different because we are looking when two population variances are equal, the information from the two samples is combined to make a pooled estimate of the standard deviation. Here's the equation for that. Sample 1 minus 1 times variance of sample 1 plus sample 2 minus 1 times the variance of sample 2 over the combined sample sizes minus 2. Again, those are the degrees of freedom adjustments. And here we have the standard error for the sampling distribution of the difference of means shown by this equation with the variances equal. And here's that with degrees of freedom n1 plus n2 minus 2. And if the variances are not equal, then the standard error is found this way with our s square, the sample variance over sample size for the 1 and 2 different samples, and then we take the square root of that. And again, that's with degrees of freedom, the smaller of the two samples, minus 1. This is our decision tree. We first have to determine our sample size in order to decide whether we're going to use a z-test. And again, that's if the samples are over 30. If they're smaller than that, we need to ask, well, is it at least normally distributed? No, then you can't use either of those. We are assuming normality with these. If yes, then we need to ask about the population standard deviations. Do we know those? If no, we need to ask, are the population variances equal? If yes, we use the z-test. If no, then we have to figure out whether we use the t-test with the assumption of equal variances or not. So these are the steps for conducting our two-sample t-test for difference of means. We first state the claim mathematically with our HO and HA specified. We then identify our alpha level for confidence interval. We identify the degrees of freedom using the sample sizes and sketch the sampling distribution. We then determine critical values using our t-distribution this time. We next come to determine the rejection regions and then find our test statistic using the equation that we showed previously. We make our decision to reject or fail to reject and then interpret that decision in the context of the original claim. Here's an example where we're going to be comparing a random sample of police officers from two different towns to see if there is a difference in their mean annual income. So we're testing the alternative hypothesis that they're not equal, where the null hypothesis is that they are equal. We're looking at an alpha level of 0.01, so we want to be 99% confident. So we use this equation to get to 0.005 cutoffs, and with degrees of freedom, n1 plus n2 minus 2, which gives us 33. Continuing on, we have to find our standard error using our equation. And this time we'll be plugging in those values. And that gives us this. And the standardized test statistic, based on what we've inputted, is 0.273. Definitely not in the rejection zone outside of 2.576 and minus 2.576. So there is not enough evidence at the 1% level to support the claim that the mean annual incomes differ. They're not statistically different.